off-the-grid gravity water hoist. So let's say to lift a 4,000 pound car within a 300 pound hoist cage, that's a total of 4,300 pounds of lift tension. So we have our water tank at the top, then we have a two-way hand pump, so you can pump this lever and turn the water pump into either a positive pressure or negative vacuum displacement pump. Water has a density of 62.4 pounds per cubic foot. So here we have our water ballast tank. This has a hose that extends and retracts into the water ballast container or the tank. The tank is consisted of welded steel, the dimensions 10 feet by 10 feet by 8 feet high, for a total of 800 cubic feet minus about 50 cubic feet volume for the hose containment. So an effective volume of the water ballast tank of 750 cubic feet. And then the tank itself, or the water ballast container itself, will approximate about 1,000 pounds. Then below it is the two-way ratchet locking mechanism. So when you place it in the up position, it's locking to prevent downward motion, and then vice versa. So we have to use this equation, and we'll set the lift of the car at 1 inch per second over 10 seconds. So the total force upward on the tension cable is the summation of F is equal to the mass times the sum of the vertical acceleration plus gravity. So in this case, acceleration is velocity divided by time. So in this case, it is 1/12 feet per second vertical velocity divided into 10 seconds. So that is a vertical acceleration of 0.0083 feet per second squared, for which we convert to the metric value of 0.00253 meters per second squared. Next, we convert the total weight into its kilograms mass by dividing 4,300 into 2.2. So then we apply the summation, the mass times the sum of the vertical acceleration A plus gravity. So we calculate 19,178.6 newtons force. There's 4.45 newtons force per 1 pound of force. So that's 4,309.8 pounds force tension to lift the car, minus the 1,000 pound ballast container. So that's 3,309.8 pounds force of water in the form of the tension applied to the cable. So that's 3,309.8 divided into water's density. So you'd have to pump in 53 cubic feet of water to lift the car at a rate of 1 inch per second over 10 seconds until the car then locks on the hoist two-way ratchet mechanism. And then after this, you would remove some of the water so it rests. And then in order to bring it down, you'd have to do just the opposite. You'd have to take the slocks in the water ballast locks in the opposite direction, add more water, lift the car off the ratchets, turn the hoist ratchets downward, slowly pump water out of this unit. And the trick is to turn the locks the other way before the ballast comes up. And you'd have to have it so the ratchet locks would meet right when the car comes to the ground, the cage comes to the ground, and then more or less all the tension is removed. There might be a little bit of residual tension. So that's why it's good to have an oversized coupler a little bit, or even a groove coupler or a cylinder coupler, so you can kind of hammer it out, and then a little bit of tension. So even a little bit might be 200, 100 pounds, but it's containable if you use some telescoping removal device or a hook device to pull it out. And so again, there should be a little bit of adjustments. And also the ratchet mechanism can also have a double ratchet system to hand crank the locks for adjustment. And you can also put a hydraulic floor jack type system to do that. So eventually if you drop it a little bit, you would take off all the tension. So if you went up a little bit, you could take off all the tension and get it to the state of the art. So it's easy to just remove at 0 pounds force tension. So again, none of this required electrical power or combustion engines. It just required the mass times gravity as force weight set up in the right structure. So these structures would have to be reinforced pretty deep in order for this to work. But just think of it, if a grid down event happened and you had to work on a car and there was no electrical power, maybe you had some reserve fuel, whoever has this in their shop would then be kind of popular. So I thought about applying old world technologies into the modern world to see what we can do to harness gravitational potential energy into useful applications. Please like and subscribe, and there will be more inventions and ideas coming in subsequent videos. Thank you for watching this presentation, and have a great day.